The Intel InBoard 386 PC helps you work faster, apparently. This box here, it's got a little sticker on it. It says it's from August or September of 1990. Now, if that is the case, then it's probably quite a late revision of this board because I believe reading Wikipedia, the fountain of all truth knowledge out there, says that this card was first issued in 1987. From what I can tell, there were two types of this card. There was the 386 PC and the 386 AT. The AT, of course, was for 286 machines, so anything with that 16-bit ISA card slot and a 286 processor. This one, of course, goes for PCs and XTs with the 8-bit data bus, so the smaller slot as opposed to the 16-bit slot that you got in the 5170, the 5162 and the PS2 machines with the AT style processors. So basically this thing here would give you a 386 processor for your XT or your PC. The PC was a really sluggish machine by all accounts. The original PCs clocked in at just 4.77 megahertz, and because the data bus was slow and there was wait states and all the rest, in some cases they actually performed worse than the 8-bit machines before them, like the Z80 for example, the 6502. So it was really quite often seen to have upgrade cards for the processors, but as far as the 386 went, there weren't many of those for your XT or your PC. In fact, I'm pretty sure this is probably the only one. It's certainly the only official one that I've heard of. And the difference between the 286 and the 386 is quite vast. Really, in terms of processing power, the 386 allowed you to do an awful lot more. Specifically speaking, it allowed you to do multitasking in a proper, or in a Bill Gates way, he would say, non-brain dead way. So basically, yeah, it allowed you to do protected mode. And that meant that you could have more than one application do its work basically at the same time. So true preemptive multitasking, and that meant you could run things like Windows 3.1 and Desk View 386, so a lot of new types of application where you could actually do more than one thing at the same time. Today we take that completely for granted, but back in the era of the 386, this was fancy stuff. Apparently the 286 could also multitask, but I've tried. It's not very good at it. So this was the way to go, the 386 processor.
This video is sponsored by the very wonderful people at PCBWay. PCBWay are the leading electronics and prototyping manufacturer. If you've got an idea, you can use PCBWay to turn it into a reality. PCBWay can build PCBs from just $5 and build them for you in around 24 hours. Now, what I really love is that for people that suck at using a soldering iron, like myself, you can upload your PCB file and have PCBWay assemble it all for you. PCBWay also do 3D printing, CNC machining, sheet metal fabrication, injection molding, and so much more. They are widely reputed by us in the retro computing community as being the go-to supplier of your PCB needs. So if you've got an idea for an electronics project, why don't you give PCBWay a try at PCBWay.com? After all, that is the PCB way. We thank PCBWay for sponsoring Al's Geek Lab. Now, let's get back to the video.
Why would you buy this card? Well, it was an investment when you had already bought hardware. If you wanted to buy a new PC in 1988 or 1989 or even 1990 when this came out, or this particular box was shipped, then you could be paying for a 386 anywhere up to $4,000. That was an awful lot of money. So if you already had a PC and you purchased it in, say, as early as 1981, this card would actually work with the original PC. But if you bought a PC in, say, 85, 86, 87, maybe 88, and you decided that you actually needed a 386, then paying $495 for this might be just enough to get you by. I say just enough because there are immediate sort of thoughts around the drawbacks, especially if you're using the PC version of this and not the AT version of this. The biggest drawback, obviously, is you're still limited by that data bus, the 8-bit data bus that your cards all plug into. So let's flip this round before we open it up and have a look. It says you'll work faster when your PC has the power of the 8386. Absolutely, that's true. I'm not going to take that away from it. I mean, the main reason that I bought this card is to try it out in my PC XT, not for the speed. I don't expect I'll get gazillions more speed, but I will get speed. The main benefit I'm looking for is the ability to run those protected mode 386 applications such as Desk View, which allows me to have more than one DOS application running at the same time simultaneously. So it says here, what will the Intel InBoard 386/PC do? I always noticed that in the 80s and 70s and 60s and 50s, to a lesser extent, they always made their product names really long, real mouthful. Anyway, total side note. The InBoard 386PC is a processor upgrade board that allows your PC to run like a 386 system. I wonder if marketing were involved in there or the lawyers were. When you add this board to your IBM PC XT Compact Portable Plus or Tandy 12,000 HD, is that 12,000 or 1200? Anyway, HD, tasks that used to take minutes to finish will finish in seconds. Many programs will literally run up to 10 times faster. It says many programs, not all programs. Lotus 123 recalcs will be done before you know it, and you won't have to sit and wait for responses to your keyboard commands anymore. All of your DOS applications will work great with the InBoard 386PC. They'll just work much faster. It's very interesting because, of course, using the applications of its time, that even with the 386, you're still going to get delays. They're making it sound like everything's just going to be instantaneous. So it is interesting. It's maybe a little bit misleading. I'm not expecting, as I say, when I get this thing all set up, hopefully if it does work. I noticed that there's quite a bit of water damage or staining. The box is not exactly flush. So hopefully it's not been damaged beyond repair. Lotus 123, as it says, recalcs will be done before you know it. That's showing the kind of audience that this card is made for. Obviously in 1987 and 88, the computer games of the era weren't exactly what you'd get in the arcade or even on some of the consoles. So it was definitely not aimed at gamers, even although it might help, I guess, games that were out of your reach on the XT or the PC, now within reach. All you'd need is a VGA card and you'd be off to the races. What else does it say? The InBoard 386 comes with 1 megabyte of 32-bit memory. So the memory is actually on the card here. And it says here, and with a piggyback memory option, you can add up to 4 megabytes more memory. This simply is the easiest and best way to upgrade your PC if you want to protect what you've already invested in hardware and software. So that kind of goes to what I was saying earlier about if you've made a purchase on a PC and you actually want to take that investment further, then this was a good option. So that piggyback option there's sort of two sort of connectors or risers by the looks of things. So I guess they would kind of sit on top of this card over here and over here. So that's quite useful in a way because you're going to get no extra space taken up inside your PC, because obviously if you had to take up another slot to put a RAM card in, that's going to obviously make quite a bit of real estate taken up. It says, what are the details? The InBoard 386 PC includes 16 megahertz Intel 386 processor and an option for the 387 math coprocessor. It's got 1 megabyte, it says 1 MB. Notice how the terminology has changed over the years. 1 megabyte of 32-bit memory plus an optional 2 meg or 4 meg piggyback memory boards which fit in the same slot, just as I've covered there. Interesting that it's 32-bit memory. Obviously it's 32-bit because this card here, the CPU, handles the memory. So any memory that you've got on your existing PC or XT, I'm assuming is actually redundant. Like it won't even see it because that memory will be slower than the memory on this card. And it would have to then bury through into the motherboard to get at that memory in any case. So I'm reckoning that it's just going to say, no, I don't want to know about that memory. I'm just going to use the memory inside this card. It says switchless installation, which is cool because, you know, back in those days, a lot of the installation of cards, ISA cards, had jumpers on them to set memory addresses and IRQs and DMAs and all that sort of stuff. And it was quite confusing. So to have switchless installation would have been a boon for quite a lot of people, especially business people back in the day that weren't necessarily all that technical. There's utility software for up to 4 times faster hard disk and screen performance. I'm going to check out how that works. I don't really know. The hard disk, I'm assuming, is just through a RAM disk, so make use of this memory on the card to speed up or add a cache to the disk. But what I'm not quite sure is the screen performance. How does it increase the video performance? So not quite sure there, we'll find out. The ability to speed up all major DOS software, including Lotus 123, AutoCAD, DBase 3, and of course Microsoft Word. And this again is a kind of sign of the times because, you know, in the late 80s, before Microsoft got to be the dominant force with Microsoft Excel, Lotus were king of the crop with 123. AutoCAD was Autodesk's CAD software, computer-aided design software, and Ashton Tate's DBase 3 was the database software. So very much showing a world before Microsoft were dominating in the Office software suites. The only one from Microsoft there is Microsoft Word, and even then they were still playing contender with another bunch of word processing software out there. This one is useful for me. There is an ability to run 386 based multitasking software such as Microsoft Windows 386 and DeskView 386. It also supports the top version, I guess, of LIM's extended memory manager, the Lotus Intel Microsoft, that is, version 4.0, so there was no more EMS after version 4, but many applications started moving to XMS. Authorized, compatible with all the PCs of the day. So there you go, so that's what it says on the back. I'm going to open up this box now and see what's inside. Alright, let's get this box open. Now, this box is not in great condition. It certainly looks like it's been somewhere wet at some point. And, you know, it is, you know, 35 years old now or something like that. God, I'm old. And it also stinks like it's been in a smoker's house. I'm almost definite of that. It really stinks like nicotine. So that's good. But yeah, let's cut into this thing, and maybe I shouldn't cut it there, but oh man, oh, just got a whiff of that nicotine. People, if you smoke, start thinking about not smoking. If it's doing this to a box, I cannot imagine what it does to your lungs. Okay, let's see if we can't get this out of the box. So, like, first looks in there, it's all kind of like well packaged. It's pretty good. That's good. That's what I want to know. It's like a kind of anti-static prevention mechanism. Ah, there we go. All right. So what have we got? First glance, we got a box of. They look like spacers for the far end of your PC to hold the card in because it's that long. Now the IBM PC 5160 and the 5150 had sort of spacers or holders or whatever you want to call them on the far end, so we'll see if that's what these actually are. I'm just guessing, or at least this one is, that's what I think that is. Not so sure about what these are, but we'll find that out. There is an installation guide. Now for a switchless machine, obviously it's quite a chunky, quite a hefty installation guide. So that means obviously that there's software or configuration settings that you need to do when you get this thing plugged in, but at least you don't have to change jumpers on the card, I suppose. I do kind of like the Tag Heuer display. I wonder why they went with the Heuer branded stopwatch I don't know, marketing, whatever. This installation guide helps you quickly put the Intel InBoard 386 PC to work. And then we got a separate, this is all in shrink wrap, talks about it. Lotus 123 is an addendum on the back there. It's an extra piece of paper. I'll open this in a second. Intel products get you online with CompuServe. So this is, I guess, is one of those sort of things you send away for. Your world to a window to a world of news, applications, support, and technical assistance on Intel PC enhancement products. So yeah, it's an ad for CompuServe. If you have memories of CompuServe, let me know in the comments. I only once actually used CompuServe and I thought it sucked. And it was very, very expensive where I was in the UK anyway. I'm sure it was in the US as well. But yeah, that's an ad. And then there's Intel Faxback, and bulletin board services give you a fast customer support 24 hours a day. There's like a little cutout card here. You can call a number, which is a BBS, bulletin board system, if you're not aware of what that is. So yeah, completely useless at this point in time. You could connect to the BBS at 300 bits per second. Wow. That is slow, so that's good. Totally useless. And then we have the box itself. Attention, static devices handle only at static safe workstations. Reusable container, do not destroy. They're thinking about reduce, reuse, and recycle as far back as 1988. Here we go. So I've never seen a plastic container quite like this one before, so it kind of looks like it splits apart. Yeah, like that. And there underneath it looks to be a card which is almost never, well, it has never seen the light of day in 25 years. So that's the back end of the card there. And note obviously that it has the 8-bit connection on it, not the 16-bit longer ISA. You can see they probably used the same box for the 16-bit version, the AT version, because this cutout bit goes that far along. All right, I'll take it out and show the front of the card. Here we go. So let's point out some of the obvious things. So an i386, 80386 processor, which is 386DX-16, and then underneath that it says SX213. I'm not fully familiar with that part, but I think that means it's got nothing to do with the SX range of CPUs. The SX were like the cheap version of the CPUs. I'm not actually up on my 386s that much myself, because I guess I'm about to, because I never had a 386. I do have something up on the wall here, which is as close as I've ever gotten to a 386. It's this sort of ornamental thing. Sorry about the glare there, but you can see that it's got the die of the chip inside it. That's what the chip looks like, heavily zoomed in, and obviously that's the actual chip. This little tiny thing there, that's the actual silicon. So yeah, if you ever wanted to know what it looked like on the inside, zoomed up, that's an example, I guess. So yeah, so that's the chip. Obviously, there's the 387. So 387 being the math coprocessor. This is a crystal, and it is rated for 32 megahertz. So it must mean that it's divided in half at some point to get us to the 16 megahertz, which is provided by this chip here. Now, apparently it has 1 megabyte of onboard memory. Just having a look at there, we can see they've got 100 nanosecond memory, Mitsubishi RAM. It's 256 kilobit memory chips to make up a full bank of 1 megabyte as we expected. So this here and this here, they're the sort of piggyback connectors. So those piggyback boards would sit on top of there to give you another 2 megabytes or 4 megabytes. Obviously there's a bunch of control logic around here which tells the PC or the XT how to operate, so I'm assuming that there'll be some sort of DMA controlling. A lot of the stuff which is actually on the motherboard itself that does whatever it does is probably disabled and is told to operate from this card right here. So that's my assumption, definitely not saying that for sure. And I notice also inside here we have the ribbon cable. Now, this ribbon cable is like gold. One end obviously plugs into the connector up here, and the other end plugs into the CPU socket. And you can see this connector here. They actually look not gold plated, but I will show you the 286 expansion board that I have in the XT in a moment. It has a very similar connector ribbon cable, and that cable is very small, and the connectors on it are very, very brittle. So if you lose one of those pins, it can be all over. It's only a 40 pin connector obviously, so in theory you could build one yourself, but I wouldn't want to try it. But yeah, that's how it plugs into the main board. So it's nice that it's given, you know, a reasonable amount of length, because you don't want this to be very small, just in case where you plug it in is far away from the CPU slot itself. So that's it. It's not very, not very movable, I gotta say. You don't want to bend, it doesn't want to bend too much. It's not like really loose like a normal floppy disk cable is. All right, so that's everything out of the box. All right, first things first, let's crack into the book. I hate taking the shrink wrap off things because, I mean, immediately that's the value gone. I put this up on Reddit yesterday when I was about to open the box, and somebody said that they were going to cry when they saw me opening the shrink wrap. So, yeah, sorry, but I guess it has to be done. I mean, we could leave this stuff in its bags forever, but ultimately, you know, I want to use it. So, yeah, let's do that, and hopefully we'll just keep it looked after. All right, one have manual, one floppy disk, and one card with some notes about 1, 2, 3 on the back there. So this floppy disk is maybe a little bit, yeah, it's definitely crooked. Don't know if you can make that out there, but it's not what I'd call flat. So that's not so great. Hopefully it still works, but if not, maybe I'll be able to get the download from archive.org, because floppy disks be failing after 35 years. Anyway, so there's a floppy disk with the installation and the utility diskette for the InBoard, and there's the manual. Let's have a look quickly at the manual. I won't take you through every page, but let's have a quick look, see if there's anything of interest in here. So how to save time, basically there's an intro, there's the PC XT installation, which we're going to do. There's also one for the PC. The main difference between the PC and XT, of course, is that the PC was the original PC and it came with only 5 expansion bay slots, whereas the XT came with 8 and a bigger power supply and a hard drive. And then there's ones for the leading edge, which was a common sort of PC clone. There's the Tandy 1200 and the compact portable. So obviously we're going to use this chapter 2, and we're also going to look at chapter 7 as well for installing the InBoard software. So it's talking about the options there, where you can get 2 meg or 4 meg piggyback. You can get a 387 math coprocessor, performs floating point arithmetic 8 times faster than the 8087. I thought that section 2 was for, chapter 2 was for XT. Where am I going wrong here? I thought that was XT. 1, it goes 1, then 3. Where's the 2, man? Chapter 2. 2-1. 1-1. 2-13. This book is out of order, man. That's not right. It's like the book is missing a whole section. Missing the section that we want to read as well. Well, I never. Not very useful. So I will download the version online and look at that. You never expect that. So that's a totally useless installation guide. I mean, I suppose we could look at the one for the PC and it will be very similar. Prepare your computer, run the diagnostic software, and then what it says down here is you must reset your computer's memory switches. Basically there, it's telling you to use the chip extractor to remove the 8087 and the 8088. And then after you've got the rocker switch set up, you install the board and you put the cable into the appropriate section and then slam it in the board. So it's pretty straightforward, pretty easy installation. I think the main thing to do is configure the memory appropriately. So this is the 5162, which originally was a 6 MHz 80286. I then upgraded it to a 10 MHz 286. Check out my other video if you're interested into seeing how that was achievable, because it was locked down by IBM. IBM said no, it's not going to go faster than 6 MHz because we'll build in things in the BIOS to stop permitting you to do that. So I managed to upgrade it anyway to a 10 MHz system, and that works very, very well. And then I finally upgraded it to a 386 cum 486. So if we run info plus, it should tell us the speed of this machine. So it reckons it's an ISA AT clone, which of course it is, and it reckons it's got 486 CPU there, as you can see. So let's have a look at the performance. Okay, so right now we're seeing that the machine is running at approximately 14 megahertz or 13.46 megahertz. Okay, and the performance is not great, but it's not terrible either, and it's identifying itself as a 486DX here at 23.369 megahertz, but for whatever reason it performs at 13.46. So yeah, it's not fantastic. Landmark thinks it's 13.46. So theoretically, what I'm going to do is, this is an AT machine, right? So theoretically it should be working faster than an XT class machine. So we're going to run that performance check on the XT class machine and see what it comes out at. So 386 cum 486, and we're going to see what the XT runs at and compare the two. Oh, it's a chunker. The IBM PC XT 5160. Right, let's have a look. Right, sorry about the flicker on this. It's running at a slightly different refresh rate on this XT. Now, first thing I want to tell you is that this XT has a 286 upgrade card in it already. So what I'm going to show you first is the machine running with the 286 card in it. So let's have a look at speed test again, and let's have a look at how it performs with the 286, of course. So it's on an 8-bit data bus, so even with that 286 card, still running well slower than the machine that we were looking at on the AT there, the 5162 with the 386 cum 486 processor. So right, okay, so now I'm going to flip the switch on this, on the turbo card, and that will reset the computer, as you can see there. So it basically switches out the CPU from the 286 and then switches it over to, I think, what is now the V20, but basically an 8088 CPU. So it's running around 4.77 megahertz, probably a little bit faster than that given that it's a V20. Let's taking its time. Yep, so it's detected a NEC V20 and it sees it at 4.786 MHz. It sees the CPU cycles at only 3.01 MHz. So really, really slow. 3 MHz AT is the comparison it's making. So that's the sort of base point that we're going to consider this particular machine as, because we're obviously going to get rid of 286 upgrade card and we're going to replace this with the 386. Right, being a good citizen of the retro computing society, or whatever it's called, means that you copy that floppy whenever you get one. And because this floppy here, since that floppy disk might be a unique version, it might be a slightly newer version or a slightly older version than other ones that have been archived, I may as well back it up. So I've got, first of all, this is a disk head cleaning disk, I guess. If you've got one, or if you ever want to get one, you can pull the middle out. And I just give it a little spray, put a little bit of isopropyl alcohol on there, and now it's all wet and smells a lot. I'll slide that back in. And this is kind of like good enough for cleaning the heads if the heads aren't completely yuck. I would give the heads a complete running over if you've never used the drive, if you know that the drive is unconditioned effectively. Give that a few runs through. You can hear it making a lot of noise. Now that should be enough. So that's stage one, and then stage two, I'll pop the floppy in. But what I'm going to do, if I can read the disk, I will take an image of it. So just a very quick, have a look at the drive. It's making a lot of noise, but it looks like it's working. Awesome. So in the utils folder, I have a directory called disk image, and that's Michael Brootman to the rescue. And I think I have to remember how to use this. So I think it's the disk drive number is 0, because that's the A drive, and then it's an old floppy disk drive. It's a 360 kilobyte disk, so that would be 40 tracks, and then it's a 2-head or 2-sided disk, and then I think we have got 9 sectors per track. Let's have a look and see if I'm right. This is great for archiving if you don't have something like a grease weasel. Here goes nothing. The floppy disk is obviously reading, I'm sure you can hear that, and the hard drive light is flashing away as it creates the file, so this is good. And we should get up to 40, I guess, because 40 tracks. That looks good. So there's my Intel above board disk image. Amazing. Well, I finally managed to get the instructions off the internet, so yay internet. And so I'm just going to follow the instructions because I don't want to make any wrong moves. But let's have a look. So before you start, talking about the piggyback products and the Eidos 387 math coprocessor, we don't have any of those options. So basically, these are pretty straightforward instructions. I'm going to be honest with you. Turn off the power switch and remove the cover and remove boards from slots 5, 6, 7, and 8. So, okay, let's do it. And I'll earth myself first, obviously. Get rid of all that nasty static. Yeah. There we go. So number 8 is over here. And number 8 just so happens to be the 286 accelerator card, the ORCID card. 8765. Let's take out the memory expansion card first, which is 1, 2, 3, 4, 5. This is the Monotech PC's micro RAM, and I've got it configured 256 kilobytes all the way up to 640. So I think this machine is going to be set up for 256 kilobytes of RAM without that board in it. Next one is the disk drive controller and the serial port. Deluxe floppy again by my good friend Jacob at Monotech PCs. So I'm just going to leave that out there. And then finally, the 286 card. Now this one is pretty tough to get out. So I'm going to remove the power cables from the power supply. The problem with it is it's got such a short cable. It is really jammed in there. There we go. So that's the Orchid Tiny Turbo 286. So you can see the way that comes together. It's got this kind of riser, I guess, on top of it, and the riser has the NEC V20 there, which is the equivalent of the 8088 processor, and it has the 80286 processor over here. So that's the new brains, as it were, and that's an 80287 math coprocessor. So I think that's sitting at, I think it's 8 megahertz. So that's a daughter card that was in this machine already. Next, I'll take the daunting step of removing this ribbon cable from the CPU socket. And again, it's just really, really carefully does it sort of stuff. Oh, always very trepidatious. And I seem to have bent one little pin there. It's I don't know whether that was bent already or whether it was just, but these pins are really delicate. They're gold pins, and yeah, they are tricky. So the next thing you got to do is disable conventional memory on the system board down to 256 kilobytes. And fortunately, the manual's pretty helpful with that. I don't have to go looking it up on -0 degrees or something, but it looks like basically all of the settings, all the switches are set to down with the exception of 3 and 4. Done. It does say actually here, if you have an add-in board providing additional conventional memory, either remove the board or disable its conventional memory. It talks about the Intel above board, which I do have, but not in this system. So basically, I will just forget about the extra memory for now. And obviously now that I've removed the CPUs, I'm ready to insert the 386. First thing to do is get the cable. And the moment of truth where we insert this cable into the socket on the motherboard. We've got to line up pin 1 with pin 1 hole on the slot, okay? Now the way that you can tell which is pin 1 on these is pretty hard to see there. I'll just see if I can zoom in and show you. You might see there is a little notch just there, just on the paint on the motherboard there, just on the paint there. So the white notch. So that helps you find out which end is for pin 1. Unfortunately, on the cable itself, it says 1 there, so we're pretty sure that that's the first pin on the connector. This is going to be really fiddly, unfortunately, so I'll try and make some space, but basically we need to get this very inflexible cable into that slot perfectly aligned. That was a very tense moment, I can tell you. This just looks ridiculous, doesn't it? It really does. It's a big flappy thing. Alright, so the recommendation is to install it in slot 5 or 6. If we have a look at the motherboard, you can clearly see, or the case, you can pretty much clearly see why it can't be slot 7 or 8. It's going to hit the floppy drive. I'm going to go with that slot. So that's 6. Now what you might see is that there's a supporting bracket on 2 of these, on the 2 rails, I guess. This slot 1 here and slot 4, I think that is, or slot 5, but not one in the hole for slot 6. So fortunately, Intel were kind enough to provide us another one of those. So I'll just line one up. I think it goes this way. Okay. Let's introduce the card to its new home. In it goes. And then I guess like that is the way it goes in. Probably want to put in floppy disk drive controller at one point, but let's just see if it works without it, I guess, first. So there we go. That looks terrible. You know what? Maybe I do want it to go in slot 5, simply because that will stick up quite a lot. And I don't know if the case will close. Even that is quite a bend. Very interesting the way that they chose to design that. That seems a bit odd. Okay, this is kind of the moment of truth, I guess. The situation where I really hope that it doesn't blow up. Let's power on. Aha! So we might get a count of 256 kilobytes, or we might get a megabyte. It's gone past 256k, that's for sure. Might just count to 640. Yep, it's probably going to have trouble. Yeah, trouble with the floppy drive, obviously, because there is no floppy disk controller. That's fine. It freaking works, as Adrian would say. Okay, well that's a good sign. Let's have a look at speed test. Okay. Yo! Look at that! So it recognizes the processor straight away, a 386DX running at 16 megahertz, and it reckons the speed is comparable to a 20 megahertz AT system. Yeah, sitting around 19.77. Obviously a little bit sad that I don't have a floating point unit, the 387, but yeah, this thing works. It's running, and it's running pretty fast. So whilst you can see that the InBoard here is providing that full 640k of RAM, there's obviously 1 megabyte of memory in the system. In that card, there's 1 megabyte on the chips. So let's have a look at the utilities and the drivers that comes with it. Okay, I'm obviously too dumb to figure this out, but the InBoard memory is, in extended memory, is 256k. I would have thought it would be 384 because 1024 minus 640 is 384. But yeah, I'm obviously not picking it up the right way. Anyway, that's fine. So I don't want any disk cache. I don't think I want any expanded memory. I'm going to keep the EGA BIOS in the new RAM, so that will increase the speed of the display, which is cool. Something like that. Oh no. So that just worked, and I think all I did was tell it to use the C drive as opposed to a C directory. Yeah, pretty weird. All right, So now we have no XMS. Interesting. So I believe that to get more of the memory, so to change the extended memory setup, you would use the InBoard PC.sys driver. So let's have a look at what it did to the config sys. It does load it. I wonder if I can do a device equals c:/dos /himem.sys. I wonder if that works. No, it does not. But maybe DOS itself doesn't recognize the XMS in the same way. So you can see it go through its memory check really quickly there, and then it finds all the memory using the ILM 386 setup. And this is a driver that sets up both extended and expanded memory, so theoretically both XMS and EMS, if you like to say it that way, because that's the way I do. But I don't really understand why it gives you like both, and I guess there might be a way to switch it off, but at the moment it's taking most of it for extended memory and then giving you 48K of expanded memory. And the problem with it as well is because it's a third-party driver, it won't actually show up as XMS in the MEM tool for DOS. You can see the EMS, however, when you load that driver. InBoard driver itself is using up 36 kilobytes of RAM, and the ILM itself is only using 3, so it's not actually that heavy, but still every bit of memory counts. So you know, before you're using the InBoard driver, you're actually pretty sweet memory wise. But this, you know, if you want the extra functionality that the InBoard driver provides, then you're going to lose about 40K if you want the expanded and extended memory driver there as well. It's quite interesting that it does detect the XMS and the EMS, so there's obviously, it's being presented to the system, although MS-DOS doesn't see it with the MEM command. So yeah, interesting. So the tool iSpeed PC allows you to change the speed of the PC. So for example, I can go 1, which is the slowest speed, and 4 is the fastest speed. Let's try the slowest speed, right? Now we're inserting 30 wait states. Oh my gosh. Well, I can already see it slower, a lot slower. What does Landmark make of that? I think that feels even slower than the IBM PC. It's real slow. Yeah, so it's about the speed of the PC itself, the PC XT. Yep, pretty slow. So now it's full speed ahead. Power. So these are some statistics here. We've got the current state, which is 4, the full speed of the machine. Apparently it's running with 0 wait states, even for the hard drive as well. So the system BIOS is running in 32-bit mode as well as the EGA. So it's kind of caching the EGA calls, which is cool. It is now the next day. I had time to switch things on again and run Jim Leonard's top bench. So at the moment it's getting a score of 17, and yeah, that's running all these particular tests over there, as you can see. So it reckons that it fairly closely matches a PS2, an IBM PS2 50Z with a 286-10 CPU in it. I don't really know if that's actually true. What I also find interesting is when we change the profile, so we step it down to 3, it goes down to the performance of an original IBM PC AT. So it's quite helpful if you're trying to emulate a specific system. And if we go down again to 2, it's coming right down to basically a decent IBM clone, XT clone. So yeah, basically an XT, a little bit better than the standard XT, maybe with something like a V20 CPU. And if we go right down to 1, it's pretty much on par with a 5150, the IBM PC, the original, but just with a V20 CPU in it, and or the Tandy 1000. So there's an example of Jim Leonard's top bench running away there. Score of 5, and then stepping through a score of 8, a score of 11, and finally a score of 17. So just another way to look at the performance. Let's have a look through, check it. So system information is as per what we'd expect. Seeing a 386 XT machine, I guess that's the way that it presents itself somewhere in a BIOS ROM or something like that. If we have a look through the memory map, we can see that everything looks fine in there, as we'd expect. Interrupts wise, everything's normal. If we do a benchmark, let's have a look at the benchmark. It brings it out at 16 megahertz or 15.99, and it's detected obviously no numeric processing unit, Math CoPro. It reckons that we are about 8.68 times the performance of it. So there's the PC speed up here, the PC XT I should say, and there is the 386. So significantly faster in both terms of raw CPU as well as mathematical processing. It's coming up and showing the memory as we expect. So it's got the 640 kilobytes base memory and the rest of that megabyte in extended memory. So it's actually found that whole memory throughout the system, which is pretty cool. I'm just running Norton sysinfo. What I do find interesting is it doesn't make, perhaps it doesn't make BIOS calls in the same way that the other tools do. So obviously this one sees 256K of extended memory, whereas the other tools show 384K. So that's interesting. What I also find interesting is the fact that it says it's a PC80 ISA bus. So it sees a 16-bit bus and a 386 processor. Just I guess a little nuance there, which is quite cool. Not entirely sure whether this will work or not, but here is the Monotech PC's micro RAM. Now I had this card in the system before, so that was fine, and it gave me the conventional memory that I needed to take this machine up to 640 kilobytes of RAM. Now I've switched off all of that because of course the main conventional memory, the 640K, is now coming from the Intel InBoard there. But what I'm wondering is if I can get that extra high memory area, this block here, there's a few extra bytes of RAM that I can squeeze out of it. Now, what I don't know is whether that will kind of work in conjunction with this card, because this card, obviously all of the memory is kind of running here. So that provides the 1 megabyte of RAM, and would it have to somehow magically go back to this card? I have absolutely no idea, but I've switched off all the conventional RAM, so all I would get is that memory between 640K and 1 megabyte. Now this I don't think is actually giving that memory. There's a kind of space, the hole if you like, between 640K and that 1 megabyte that is not provided by this card, I think. So all I've done is enabled the two spaces here at the end of the card. Don't know if you can make that out clearly, but D000 to E000 and E000 to F000, because when I ran check it, it said that those areas of memory were unallocated. So my thinking is maybe that'll work. So I'll give it a shot and see what happens. Tell you what, getting cards in underneath this cable for the onboard or the inboard, pretty tricky, not gonna lie. Right, I think that's it in. To make use of the memory on a system like this, because it's not a full 16-bit machine, Microsoft MS-DOS didn't actually know how to allocate this memory back in the day. So you would use DOS equals high, and then obviously use high memsys, and you could use the UMB. But I think that was like for 286 and above. So on the XT, you had to use some extra fancy little drivers, one called use UMBs and another one called DOSMax. And what DOSMax would do would be reallocate DOS into that UMB area. So that's what I'm going to do now. Let's see if that works. Also, another thought is, what will that do to the performance of the system? Because it might have to swap out of the 32-bit mode it is running on inside the card to access MS-DOS, which would be then in the 8-bit mode. So I'm not 100% sure this is a good thing, but you know what? I'm just going to give it a try and see what happens. So I'm going to do DOS equals UMB, not high, and then I'm going to enable device equals use UMB, and I'm just going to do to F000, and then I'm going to do DOSMax shellmax C:E256-P. That looks about right, and I'll save that. I'll Control Del. See what happens. Okay, well, it didn't crash. And it says that it's located command.com at D001. So now we have an upper memory block where we have 123 kilobytes for free, and we have still 0K in XMS, but at least we have more memory free in conventional space. And we can have a look at how that's worked out. If we do mem/c, we can see that conventional has loaded, we've got this use UMBs here, and also command has been reloaded as well. 4K of that has been used here for command.com. So theoretically, I think we've got a little bit more space than we did before. So the Intel InBoard 386 PC helps you work faster. Is the claim true? Well, I would like to say yes, but also no. The only drawback really with this card is that the memory it has on board, built in, is 1 megabyte. In standard MS-DOS, you get 640K, and then there's just a dribble left of memory after that sort of 1 megabyte space. So there's not really that much to do if you need the sort of 386 power-hungry applications. Now, there's a fella called Harrison Frazier who is on Vintage Computer Forums. You should check him out, because what he's done with the help of a few others is built a board for the InBoard, which gives you the ability to plug in those extra memory modules. So you can plug in some SIMs and you can get up to 4 megabytes of memory. So I've ordered one of those from Harrison, and hopefully that'll be with me from the United States of America really soon now, and I'll make another video following up on that progress. But basically, as it is with 1 megabyte, there's a certain limitation to how useful it can be. For example, I've got here my installation of DeskU. DeskU is not Microsoft Windows, it's a kind of multitasking platform which allows you to swap between applications, but actually more than swap, it allows you to multitask. Now, if I had enough memory, I'd probably be able to completely multitask, i.e. have two applications here running in real time side by side. But as it is, because I don't have enough memory, you can see that when I go over to this here, let's have a look at the memory first of all. When I go to memory status, it says swapping up the top right for starters. And it tells me that I've got 0 in the way of expanded memory, and I've got common memory and blah, blah, blah. So I can kind of switch between windows. I can go back to number 1 here, and then that will give me my bulletin board that I can zoom the window off and I can see. And everything is hunky-dory, which is great, because before I wasn't able to do that. So I can run multiple applications side by side, but I have to swap them to get them to come back to each other, right? So I have to press this A key and then switch windows, choose the second one, and then swap. So it stops this application running and then swaps over to this one here. So this, I can do stuff on this, like I can do that, /S, and off it goes. And then I'll zoom out, and you can see that it's paused doing that right there. And I can swap back to the other one. But what's happening is it will only allow me to run one application at a time. Not really that helpful if I wanted to do two things at once. So say write a document and go on the bulletin board, or use the micro web browser. Either way, it's not quite there yet because I think we need more memory. So the daughter cards that were sold for these InBoards are probably rarer than hen's teeth. I haven't even tried looking on eBay other than a cursory glance, but I didn't find anything, and I didn't expect to find anything. So it's by the grace of God that some people have decided that it would be a good thing to make their own boards, that somehow they figured out how to reverse engineer it and create the compatible boards that go on the top of the InBoard. So I look forward to testing that out and seeing how well this performs with a bit more extra memory. I can't wait for that. So that's coming up on Al's Geek Lab on a future video sometime soon. And I'm going to show you another video on how to get this networking multitasking going as well. So stay tuned for that. But in the meantime, thanks very much for watching. Stay safe and be excellent to each other. Bye for now.